We've been working on Grandma's chickens since we first started learning MakeCode for Minecraft. It's had several iterations, and I think we will continue revising it for a long time to come to make it more interesting and entertaining. We were inspired to do this game because of the chicken rain on Microsoft's MakeCode for Minecraft site. When I saw all those raining chickens, the first thing I wanted was a fence, and then of course I couldn't resist killing a few chickens, and then of course I wanted to keep score, and it was game on. Okay, let's take a look at Grandma's chickens. And I think we'll enlarge the screen before we do this. Okay. The first thing Grandma's Chickens does is build a fence, and it puts this clear block at the center of the fence, and that's where the player is. As soon as the player sees some chickens, it can start killing them, and they will continue to reign inside the fence. Now, notice I'm using a sword, which means I only have to strike a chicken once to dispatch it to the chicken otherworld. Now, as I dispatch these chickens, notice there is a score being kept in the sky. And unfortunately, there's been several lightning strikes, and look, it made a hole in my fence. And had there been any chickens left, which I think there's not because so much of the lightning strikes got them. Okay, so anyway, my score here was 15. Now sometimes the score being printed in the sky runs a little behind the actual score. So I have it printed out here at the bottom where it is showing 15. So that's that. Okay, let's move. This is going to move us 200 blocks to the east into some pretty clear area. And this time I want to use my hand to play the game. It makes it harder, but I think it's actually more entertaining. The reason it's harder is that it takes several strikes to kill a chicken. And if you hit the ground, it makes a hole. And also, if you accidentally strike the fence, it breaks the fence and the chickens can escape. So let's run again. And there is the fence. There is the center. I'm at the center, and here come the chickens. Now notice they're not being killed when I strike them. Oops, got a hole in the ground. But I strike them just once. To be really careful when you're hitting them near the fence because you can easily make a hole. Whoops. You can even make a hole in the ground that lets them go into the ground and escape underneath the fence. Whoops. Got him in the corner. Whoops. I'm not sure that he burned or whether I got him. Boy, these little boogers. Whoops, there he goes, outside the fence. And I would have to go over the fence to get him, and I don't think I can oops, you little, that was a dumb chicken. Okay, looks like that's it. What was my score? 11. Okay, well, that was fun. Pretty much devastated the fence. Okay, let's go back and look at the code to Grandma's Chickens. Okay, the main code, there are two main parts of the code. One is the big run code, which, as you can see, is kind of long but easy to understand when you break it into its parts. The other main part is the on chicken killed. So this is what happens when a chicken is killed. It's an event that's triggered on a chicken killed. Now, it's only when the player kills a chicken. It's not triggered if an ocelot eats one or if the chicken is struck by lightning. Too bad, but in a way that makes the game a lot more interesting. Okay, the run command has 3 arguments. I also call these parameters. In fact, all programmers might call these parameters. num1, num2, num3. The first thing the program does is set the origin, and I've talked about that in another post. It simply sets a global variable called origin to exactly underneath where the player is, but the Y position is as if the player were standing on the ground. So the player might be flying, but origin is under the player, but it's at where the player's feet would be. Then it has 3 global variables. In blocks per fence side, which is the argument num1, in chickens, which is the argument num2, and in ocelots, which is the argument num3. Now, you don't want to try to use num1, num2, num3 as the global variables because that would truly make you crazy. You need to introduce these as global variables. Now, you might not need them as global variables. In fact, well, if they're only local, that is used only in this run command, they wouldn't have to be global. In any case, these are easier to understand than the values num1, num2, num3. Then I like to say, so that I've printed out the value of these variables, because sometimes I've had problems with the arguments being 0 no matter what I typed in. Now, in my earlier examples, when I was saying run, I had no arguments following it, which means it took on the value of the defaults, which is determined by this code. If the number of blocks per side is less than or equal to 0, obviously that wouldn't work so well, then we set it to 15, and that's the default. If the number of chickens is less than or equal to 0, in other words, negative or 0, the game would not be very interesting, so we set it to 50. 50 chickens. Of course, you could specify 100. I've actually wondered what it would do if I specified 100 chickens in a 4x4 pen. That'd be kind of cool. We might do that in a minute. Let's just do that. I like playing. So let's move. I named it Move Me here. And then let's say run. And the number of blocks per side, we'll give it 5 blocks per side. And we're going to put 100 chickens. Okay. There's the fence. Here come the chickens. I'm not going to start killing them. I just want to watch to see what it does. They are really piling up. Oh my goodness. Oh, and look, they're piling up on top of each other so that they can get out. You know, they normally can't get out if the pen is big enough, but oh my goodness. Oh my goodness, look, look. Now, that wouldn't be hard to kill, would it? All I have to do is click anywhere in the pen and I'm getting them, I'm killing them. Yes, 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 yes. What if I had the sword? I'm making minced chicken meat pie out of them. And of course, those ocelots are eating them pretty fast. Woo, and there comes a lot. Oh, that took them out. And gee, it didn't get the fence, which is kind of surprising. Okay, so how many did we get? 12. Actually, it looks like if we look up into the log, it looks like we got 14. Yep, 14. Okay. Well, that was fun. Okay, let's go back to the code. Okay, stop. Actually, it looks like the score went to 17. That's cool. 18. See, the event can get behind, and there can be so many events generated that it will still queue them up and run them one at a time. So our final score was 18. Okay, now things have calmed down a bit. Let's go back to the code. Now, you see the fun you can have with these variables. Of course, what if you put 50 chickens and, 50 ocelots? That game wouldn't last very long, no matter how big the pen was. And you wouldn't even have to strike any. Of course, you would score 0. Okay. After I set the values of the arguments, in case they need to be set to the default values, I save them out again, just to verify. This is kind of a debugging thing. And when I'm debugging, I want to look at every variable to see, what its value is, so that I have confidence that my code is running as I want. The next step is to calculate the fence characteristics. And this, of course, is based on the number of blocks per side for the fence. And the first thing to do is to say, is the fence blocks per side even or odd? If it's even, I actually want to increase it by 1. Why would I do that? Well, if there's an odd number of blocks, then there's a block immediately exactly in the center. And there would be an even number of blocks on the left and on the right and in the front and on the back. So there would be an exact center, which is not required. It could be one off, but I like being meticulous. It's kind of a programmer thing, so not necessary, but I like it. It actually does become kind of important if your fence is really small. Like, see, how small can this fence be? Well, it could be, right here it says, if it's less than or equal to 0, then it gets the default. Could it be 1? Well, let's see. One. Okay, well, obviously I need to change the code, and I will for the download version, because 1 just doesn't work very well. Does 2 work very well? Two blocks per side. Well, that's not bad. 2 blocks per side works just fine. Of course, there's not much of a place to put the chickens, but there they all go down to the center. Notice that if it was 2 blocks per side, it increased it to 3. Okay, enough of that. Back to the code. Okay, chickens. Hey, chickens. I think I'll move. Thank you. Back to the code. Okay, I'm just going to go ahead and change this. So if the number of blocks per side is less than or equal to 1, and really, even if it says 2, it increased it to 3. So why don't I just say less than or equal to, yeah, 2, that works. Then it takes on the default value. Now, the number of chickens can be You can have any number of chickens, but if you're going to set it to 1,000, for example, it's going to take you a long time to rain down all those chickens. But of course, that would be fun. And the number of ocelots has no upper limit, but the default is 3. And then, as I described before, we say the value of the 3 arguments. And here, now we're back to where we were. If the number of sides is divided by 2, if the remainder divided by 2 is 0, that means it's an even number. So I increase it by 1 to be sure it's odd and has an exact center. Then we say the number of blocks per side again to see how it was changed or if it was changed. Then we want to set the number of blocks to fence center to be the number of blocks per side minus 1 divided by 2. You can figure that out for yourself to verify that it is correct. It is correct. Then we're going to say where that is. And then we're going to set the 2 corners of the fence that we're going to be using to build the fence. The northwest corner is the part of the fence that's closest to the player, and it's actually at origin, which was set underneath the player to start with. Then the fence east-south corner is east and south, which means it's the corner diagonal from origin. And so that's what you need to build something. And then we're going to set the fence center to origin plus the number of blocks to the fence center to the east and the number of blocks to the fence center to the south. Okay, then we're going to teleport the player to, basically we're just going to move the player 1 step back and 1 step to the left, these are blocks I mean, so that it's not in the way of building the fence. Of course, maybe it wouldn't make any difference, the fence could just be right on top of the player. But just in case, I like for neatness reasons to move the player out of the way. Then we call the function build a fence, which I've described in another post and another video. Then we teleport the player to the fence center, which is where we want the player to be when it starts. We call the function make a pointer to the east from origin, and that's just so I can visualize how the fence was built. That is, it was built first to the east, then a turn right, then to the south, and so on until the fence was complete. And I call the function give swords, and all that does is it clears the player inventory and right now it gives him 1 sword. Now I've experimented with giving the player other things to see if it makes killing chickens more interesting, and but I settled on 1 sword. Then we set the score to 0, and we call the function print score, which prints the score in the sky, which is described in the blog post Lucy in the Sky with Diamonds. And then we calculate the boundaries within which we want the chickens and the ocelots to spawn. Now we don't want to use the fence boundaries here because we want the ocelots and chickens to spawn in an area that's just inside the fence. If they land on the fence, then they could jump out, and that's not what we want. You notice when we had a really small fence, they landed on each other's heads. That's why they could jump out. And then we repeat the number of chickens, and we spawn a chicken in a random area from the east-south corner and bounded by the east-south corner and the northwest corner. Same with the ocelots. We repeat the number of ocelots and we spawn them in a random position between the 2 corners. And that is the main routine for Grandma's chickens. But if you just stop there, that's all pretty interesting. It rained everything into the fence, but that would be all it does. Well, there's one more really important part to this, and that's on chicken killed. On the animal killed. Okay. By the way, don't worry about killing all these chickens. I mean, after all, chickens are food for all the players and all the people in the Minecraft world, so they get eaten. So they're food. So just kill them all you want to without guilt. Now, when a chicken is killed, you bump the score up by 1 and you call the function print score again. And then in 1 and 3 times randomly, you spawn a lightning bolt at a random position between the two diagonally opposing fence corners. Now notice this includes the fence, so a lightning bolt could hit the fence. And that makes things more interesting because it could burn a hole in the fence. Now, of course, the lightning bolt can hit a chicken, wiping them out before the player has a chance to kill them. And of course, that lightning makes fires all through the area where the chickens are, so it makes it kind of hard to move around. So the lightning really makes the game a lot more interesting. Okay, before we end, let's play just one more game. And just for the heck of it, we are going to spawn a lot more chickens. When we could pick a really big area. So we're going to have a really big pen, like 50 blocks per side, and we're going to have 1,000 chickens, and we're going to have 20 ocelots. There they go. Okay, I think I will there's the pin. There come all those chickens and all those ocelots. Is it still raining chickens? Hard to tell. Well, I haven't killed any. This would be, oh, still raining those 1,000 chickens. Now you can start killing chickens anytime you want to. I've got a sword this time, so it makes it pretty easy. Notice if I accidentally hit the ground, it doesn't matter if I have a sword. Of course, the lightning sure takes its toll. Now, I'm using the mouse to do this, but I could switch to using my touch screen, and it's a lot more accurate. It's really fun with a touch screen. I'm working on a Microsoft Studio, which is really fun and fast. Of course, oops. So I don't have to move around. Whoops. I'm still using the keyboard to move, although I wouldn't have to do that. I could use the on-screen commands, but I find those more awkward than the keyboard. Of course, I could just keep doing this all day. I mean, there's 1,000 chickens out there. And I don't think you want me to do it all day. Of course, you could stop watching this video anytime, but I think I'll stay here killing these chickens. What's my score anyway? 29. And do I have any holes in the fence? Nope. Still got them all contained. Whoops. Of course, I could just get somewhere and wait for the chickens to come to me. Of course, would they stop coming to me if they knew they were going to all get killed? Don't know. Whoops. Dumb little critters. Sometimes they just stand there and watch me while I take them out. That's a problem with using the screen, because sometimes you accidentally hit the controls, not the chicken. Oops! Wow. Okay, now how many? There, 32. Looks actually I'm up to 33. I bet I could reach 100 if I just keep on here. Of course, I might get hungry for lunch. You know, when I was a young girl on a very poor farm in Oklahoma, when I saw my mother in the backyard plucking a chicken, that means pulling all of its feathers out, right after my dad had killed it, either by wringing its neck or with an axe, I knew there was a wonderful feast coming up. And it was so much better than the beans and cornbread that we normally had, which frankly I got a little tired of. So that was a wonderful thing. I can still taste that baked or fried chicken. Nothing quite like it. Well, I've got 44 and I'm getting kind of tired. And see, I'm talking about food, so I must be getting hungry. So I think I'll just say goodbye at this point and remind you, for all of us, oh, it got a hole in my fence. Okay, before, let's see if the chickens kind of all go to the hole. If they were a little smarter, they might just all go towards those. Oh, there's 2 holes in the fence, and they're escaping. Oh well. Okay, I give up. We code, make code. Bye.